So we are almost done with atoms. That means the test is coming up very shortly. Be sure you check RenWeb for when that will be. And this is, once we're done with atoms, we'll be able to move on to the periodic table and bonding, chemical reactions, all sorts of stuff that's going to be great. So one last topic before we're done with atoms, and that's going to be atomic mass. Atomic mass is basically going to tell us things about the overall weight of the atom itself. So let's just refresh a little bit the things that are in an atom. We've got protons, as you know, the little positively charged things. They're in the nucleus, positive charge. We also have electrons, and as we've learned to quite some detail exactly where the electrons are. They are around the nucleus. They have a negative charge. They're also way smaller than a proton, about 1/2000th the mass of a proton. So they're much smaller, as you may also remember from the scale of the universe video that we watched early on in the class. There are also neutrons. Now we've talked about these a little bit in class. The neutrons are in the nucleus, right? And they have no charge. They are approximately the same size of a proton, slightly more massive, not more massive enough for us to really be concerned about it at this level. And their purpose is to stop the protons from flying apart, because protons are positively charged. You put two positively charged things together and they're going to push apart. So the neutrons are able to stop that with something called the strong nuclear force. That's not too important for us. That's more of a matter for physics. So, now that we've got these different things, there's different numbers that we can use to describe atoms, specifically to describe the nucleus. One of those numbers is a number called Z. That's the atomic number. That's the number of protons. That's going to be a whole number. That's also the main number that you'll see on the periodic table, because the identity of an element is related to its number of protons. You also have a number n. That's the number of neutrons. And then you've also got a number called A. That's the mass number. That's the number of protons plus the number of neutrons. That's Z plus N. And typically then, if we're going to write out a element and we want to know its mass number, we're going to write it in this format. You're going to have the symbol for the element. You're going to put the atomic number down here on the bottom left. That's the number of protons. And you're going to put the mass number, that's the number of protons plus neutrons, right up here. We will practice writing things like that next time. It's not really hard, especially compared to a lot of the stuff that we've been doing with electrons. So, the mass number is different than the atomic mass. That's what we'll go over on this slide. But before we can do that, we have to talk about something called an isotope. An isotope means you've got the same element, so it has the same number of protons, but it has a different number of neutrons. This won't change what the element is. It could change some properties. For example, some isotopes are radioactive, which means they will break down, while some isotopes are stable. For example, carbon-12. That's carbon with a mass number of 12. If we look at our periodic table, we can see that carbon has an atomic number of protons, equal to 6, which means how many neutrons would it have? That's right, it's got 6. Contrast that with carbon-14. It's still carbon, so it still has 6 protons, but how many neutrons does carbon-14 have? And it has 8. So since these numbers of neutrons are different, it can lead to different properties, and in fact, carbon-14 is radioactive and can be used for carbon dating. Now, you'll see a number on a periodic table, on a good periodic table, that's not a whole number. Well, where is that coming from? Because we know the atomic number, Z, the number of protons, is a whole number. We know the number of neutrons, N, is a whole number. So that's going to make A, the mass number, a whole number. So where is this coming from? It turns out it's a weighted average. What that means is, let's say that you had a particular isotope or a particular element that had two main isotopes. Let's say that there was 50%. Let's just use the example of carbon up here. Let's say that 50% of all the carbon out there was carbon-12, and 50% of all the carbon out there was carbon-14. Well, since 50% is carbon-12 and 50% is carbon-14, that means if you take just a bunch of carbon and find the mass of all that, it's going to have a mass of around 13, halfway in between there. So, if we take a look at lithium here, we can see that lithium has an atomic mass, again that's a weighted average, of 6.941. So, I will tell you there are two isotopes of lithium, lithium-6 and lithium-7. So looking at this mass number here, which one do you think is the main isotope, the one that there's the most of? And if you said lithium-7, you're correct. In fact, it's around, I think, 94% of all the lithium out there is lithium-7, which means, since lithium is atomic number 3, that it has 3 protons and 4 neutrons, although there is some lithium out there with 3 protons and 3 neutrons. That's going to do it for today. Thanks for listening.